So finally here, the most awaited video in all of YouTube for the GMAT, our Complete GMAT Quantitative Course. In this course, you learn everything you need in order to get a really high score on the quantitative section of the GMAT with real-life examples, theory, and a PDF with over 100 questions. Okay, so stay tuned. If you haven't subscribed to our channel, then you're missing out on a lot of things because we're posting a free course for the GMAT, and then we're going to post also a free course for the jury. So subscribe to the channel right now, click on the notification bell, and I also invite you to give us a like if you find this video useful. I truly want to thank all of our supporters, all of our fans out there who have been showing us their support and their love with their comments by sharing our videos. Okay, and by giving us a super thanks also here, because you can give us a super thanks and you can send some money our way here too. Okay, we really appreciate you guys. And also I'm happy to announce the winners of the contest we started last October. If you remember, last October we started the contest for the biggest fan of Liberty Test Prep, right? Biggest Liberty fan. And the first place was gonna get full access, complete access to our GMAT platform with over 1,000 questions and exclusive videos. And the second place was gonna get 2 hours of tutoring with me. Okay, so finally here we have the results. Here are the winners. Okay, these have been the people who have commented the most, the people who have been the most active in our social media, not only here on YouTube, but also on our Instagram, and the ones who follow us on TikTok, and the ones who send a lot of love our way. So we appreciate our most active subscribers and our most active followers. So we're about to start a new contest also, and just stay tuned till the end of the video, because at the end I'll give you indications for this new contest. Now, before starting with the theory, there's something very important I want to let you know. For those who want to stand out and are looking to get a really high score on the GMAT in the fastest and easiest possible way, Liberty Test Prep offers the best private GMAT tutoring, 100% practical and customized to fit your needs. All of our prep packages include full access to Liberty's GMAT classroom with a huge database of almost 5,000 exercises, tons of mock exams, and exclusive theory and practice videos that will help you achieve an outstanding score on the GMAT. You can visit our website to learn more about our services or get in touch with us directly via WhatsApp or Telegram. During this sales campaign, you can get your first introductory GMAT class for only $7.90. So here we're about to start with the actual lesson. Now, one thing I do want to tell you though is that this video is made in such a way that you're going to take the most advantage. You're going to get the most benefit by watching every single second. Okay, do not skip it. I mean, of course you can do anything you want, but this video works better if you just watch it from beginning to end. Okay, uninterrupted. So here we have the topics that we're going to be discussing on this video. There are going to be 2 videos for the quant section. This one's the first part, and then you're going to get the second part later on. So now, talk is cheap. We're going to start with the introduction for quantitative. Okay, now the introduction is going to be pretty quick. Why? Why? Because I'm pretty sure you already know something about quant. You already know what quant is about. At least the basic part. How do I know? Because if you are watching this video, you have already watched our introduction, right? If you haven't watched our introduction, you shouldn't really be here. Okay, do things in order, don't rush. If people who rush, usually they don't get good scores. Okay, so you already understand what the GMAT is about, what the quantitative section is about, how many questions you get, right? What types of questions you get. So just to recap and to summarize a little bit, as far as the content, you will not get tested on trigonometry or calculus, right? No derivatives, no limits, no trigonometry. Okay, on statistics, for example, you are going to get tested also, but it's going to be very basic. You will never be asked, for example, to get the variance, to calculate the variance yourself, or to calculate the standard deviation. Okay, that's not required on the GMAT. You will be given those values and you will have to do something with them. Okay, but you will not be asked to compute them yourself. So the GMAT is pretty basic regarding the content. It's not that difficult. Anyone who's taken the GMAT will tell you this. The real enemy here, the real thing that is difficult with the quantitative section is the time limit. How to be able to answer in only 2 minutes, all right? So the thing here is that so that's why we're making this video. You have to get to know the right shortcuts for you to be able to give an answer in 2 minutes, all right, with that time pressure, with that time limit. So that's a basic thing you have to learn how to do. So now we're going to start talking about something very important, and I want you to pay close attention here, okay? The types of mistakes. Now, this is one of the most important things if you're ever going to develop a preparation plan, okay, a prep program. So the thing here is that there are 4 different types or kinds of mistakes, and you should be able to identify each one if you want to improve upon them, okay? So for example, the first mistake has to do with reading. All right, some people, when they read the question, they don't understand it really because their level of English is low, right? And if you don't understand the question correctly, if you don't know what they're asking you, it's going to be very difficult for you, even if you have a solid quant, right? So solid quantitative knowledge to give a good answer. So just make sure that when you are reviewing your incorrect answers, if you're really truly understanding what they're asking you, okay? That's the first thing you have to make sure of. Second step would be those problems that derive from translating, all right, from interpreting the question. So of course, when we read a question, that's usually written, okay, most of the time, not always, but sometimes they do give you numbers, but sometimes they're going to give you some word problems. And in that case, then you have to be able to translate those words into numbers, right? If you can't do that, or if you see you're making mistakes in that, then you need to practice here. But it doesn't mean, for example, that your English is wrong. Neither does it mean that your quantitative foundations are wrong. It just means that your interpretation, your translation sometimes gets, a little lost. You get lost in translation kind of thing. So what you have to do is you have to practice with that specific part, okay? You have to practice it with word problems in order to improve that, because it's very important for us to identify the mistake carefully in order for us to target all of our solutions. Third type of mistake, operations, okay? Operations is one of the most difficult mistakes in quant. Basically, that you are making problems with basic arithmetic. Sometimes because you are rushing when you are giving your answer, you get additions wrong, subtraction, multiplication, division, those kind of things. If that's your case, if you see most of your incorrect answers are because you are making mistakes during the operation, then you have to practice a lot, okay? And you have to practice with drills, not necessarily from the GMAT. You can practice with, for example, your high school textbook, all right, or your middle school textbook. Start adding, subtracting, start multiplying, fractions, etc. Those kind of things. The most you practice, the most you rehearse is going to get you to be more comfortable during the operation, okay? And that's going to improve your score. But the important thing is that in order to solve these problems with operations, right, the mistakes you're making with operations, you need tons and tons of practice. And then number 4, time management. Okay, time management is the next problem. So maybe you are reading correctly, you are translating you're interpreting, right? Translating your question from words to numbers correctly. You're operating correctly, but then you are just taking too long. All right. So what's going on? Usually, what's going on is that you don't know the theory. Okay, and that's the purpose of this video, to give you the right theory in order for you to be able to know what to do immediately upon seeing each of the questions. Okay. So how do you solve problems with time management? Theory. You have to know the right ways to do things. So we're talking about quant, right? So there are tons of ways to solve a problem, okay? But not all of them are efficient. So here on the GMAT, you have to learn how to identify the easiest route to the solution. So now let's get going, because we're going to start learning some theory. First of all, and here again, I'll never get tired of this, I want to thank all of our students who support us, who trust us, and we got their back. Okay. Now, we also want to thank all of our followers, all of our subscribers who support us, not only through their comments, but also through that super thanks button. Okay. Now, besides that, I also want to remind you to download your free PDF with 100 GMAT exercises and video explanations. Okay. So the link is in the description. Go to our website and download it. So now let's get going. So now we're going to start with chapter number 1, Algebra. Okay. Algebra is by far the most basic part, okay? The most basic section. Here, what we want to do is to be able to know that we are okay doing basic operations with fractions, right? Addition, subtraction, arithmetic, multiplication, and division. And that also we are comfortable dealing with one variable or two variable equations, okay? So finding system of equations, basically replacing or substituting, right? And also adding or subtracting equations in order for you to get one variable, and to know the different theory about when is it sufficient for us to know that we are going to get the answer, okay, regarding a variable. So let's start watching this lesson. Perfect. So now we're going to see some basic operations that will come on the GMAT, okay, that we'll have to master for the GMAT. As you remember, the GMAT has nothing to do with trigonometry or calculus, okay, but there are tons of basic arithmetic. So for example, adding fractions. Adding fractions should be something very simple. You should remember that from high school, maybe, right? So for example, if you take 5/8 plus 3/5, what you get is actually base 40, because that's a common denominator. And then you kind of cross multiply, right? You cross multiply 5 times 5 and 3 times 8, and then you get something like 25 plus 24 over 40, which would be equal to 49 over 40, okay? And that'll be fine. If you can, then you simplify. You want to simplify your fractions. This should be fairly simple. Now we go to another operation, which is the multiplication of fractions. So here you take 5/8. Now, not adding, it's times 3/5. Of course, you just multiply directly. 5 times 3, 15, 8 times 5, 40. And there you go. Easy, right? Easy as a piece of cake, actually, all right? Now, if you want to divide something, division, you basically are multiplying by the reciprocal, right? So if you divide 5/8 into 3/5, what you do is multiply 5/8 and then take the reciprocal of 3/5, which is 5/3. So it's the same thing as multiplying, just with reciprocal. This is something very common, something you're going to have to do all day long when you're dealing with the GMAT. So this shouldn't be a problem at all. This should be something very easy, because it is basically the whole framework or the tools you're going to use for GMAT, and you should feel 100% comfortable doing this. Now, of course, when you're preparing for the GMAT and you're doing the exercises, you're going to have to deal with tons and tons of equations, okay? Usually they're going to be linear equations, okay? And some exponential, especially some quadratic equations, okay? But no more. So that's the whole let's say the whole difficulty of the GMAT, okay? So for example, equation, the golden rule they call it, right? What is the golden rule of an equation? Whatever you do on the left, you have to do also on the right, right? So here we have an equation, equal sign. We have a side on the left. We have a side on the right. So if you want to do an operation on the left, you do exactly the same operation on the right, and then we're fine. That equation holds, okay? If not, then you're changing the equation, all right? So for example, here, what I'm going to do is I'm going to try to get rid of this denominator 7. We hate denominators, we don't like them, so the first thing we want to do is we want to get rid of them. So we do that by multiplying the left side by 7, okay? Once you multiply the left side by 7, you get 14x, 2x times 7, and then you multiply 7 times 6 sevenths, which actually gets rid of that denominator, and you only get a 6, okay? But if you did that to the left side, you also have to do that to the right side, right? So on the right, again, you multiply times 7, you get 21x minus 14x squared. Okay, basically, that's what happens when you are dealing with equations. So just remember this basic algebra, basic. And then we have system of equations. So we're given an equation, usually with a couple variables, and we want to get the value of them, okay? So to solve equations, number one, you must have the same number of equations as the number of variables. That's right. So usually, there are going to be some exceptions. I'm going to show you that in a second. But if you have one equation, let's say, right, and you have two variables, like for example, 3x is equal to 4y minus 10, okay? I have two variables in this case, and I only have one equation. That's one equation. So most of the time, that's not going to be enough for me to find the values for two variables. So I need the same number of equations as the number of variables. That's what usually is going to happen. So if I want to find two variables in this case, I would need one more equation that contains x or y or both. So maybe something like y is equal to 9 plus 2x. Maybe, all right? So if that's the case, I have two equations with two variables. In that case, I know I'm going to be able to find those solutions, okay? Now, you got to be careful though. Sometimes, let's say you have y is equal to, let's erase the first equation I wrote, okay? and we are only left with one equation, and then you see another equation that says 2y is equal to 18 plus 4x. Is that a second equation? Really? Is that an independent equation? No, that's just a repetition of the first equation. The only thing they've done is they've multiplied it by 2. Right? If you multiply this by 2, that turns into 2y is equal to 18 plus 4x. So that's not a different equation. We need two different equations, okay? So in this case, we would say we have the same equation. We're only left with one equation here, because the second one is a repetition of the first one, you're just multiplying it by 2. Okay, so that's the first rule for equations. Now, second rule, you can do it through direct arithmetic or replacement. Okay, we're going to do this. Direct arithmetic basically means you're going to add, you're going to divide, subtract, divide, or multiply. Okay, and replacement, of course, you're going to substitute things into one another. Okay, so let's take here this system of equations. All right, we have two equations, two variables. We have to first make sure that those two equations are different, and they are, right? Because there is not a constant you can multiply or divide the first equation and turn it into the second. So those are two different equations. Now let's try to do some basic arithmetic. Okay, what could we do? For example, we can just multiply to get some common, right? Multiply to get some common value for x. Let's say we multiply the first one by 2 or by 3, I'm sorry, right? The first one goes by 3. What would happen if the first one goes by 3? You have 6x plus 9y is equal to 3 times 18 is 30 plus 24, 54, right? So that's the first one. And the second one I'm going to multiply by 2, so you have 6x plus 14y is equal to 50, okay? What I'm going to do is I am going to subtract the first one from the second one from the first one. That's what I'm going to do. Why? Because I want to get rid of this. So once you have that, you get 0 here, and you get here minus 5y is equal to 4. You see? That's what we get, and then we get y is equal to minus 4/5. So we have the value for y, and then it will be easy for us to get the value for x. We just plug it in here, any of them, and we get the value for x. Now, that's the way we do it through direct arithmetic. We can add or subtract equations. Now, if I want to do it through replacement, how would I do it? Let's see. First, I'll isolate, for example, x, right? I would say 2x is equal to 18. I'm using the first equation here, minus 3y, and then I'll say x is equal to 9 minus 3/2 y. Okay, so that's my value for x, and I would substitute that x into this place here. Yes, x, this one. So I'm going to say 9 minus 3/2 y plus 7y is equal to 25. That's what I'm going to say, right? So here we have 27, okay, is minus 9/2 y plus 7y is equal to 25, all right? So here we have minus 2, this one minus 2, and then let me use this space here on top. We have minus 9/2 y plus 7y is equal to minus 2, all right? We're trying to get the value for y, so let me turn this 7 in halves, so that'll be the same as 14/2, right? So minus 9/2 plus 14/2 will be 5/2 is equal to, y is equal to minus 2. So y will be equal to minus 4/5. The same thing. We get the same thing. Okay, so you have to have those two ways to solve your equations, either by adding, subtracting, or doing some other arithmetic operation, or by substituting, replacing. Okay, so now what we're gonna do some exercises for the GMAT, real GMAT questions. Okay, so we're gonna do this. Number 1, you're gonna get 2 minutes, which is the average time you get for each quantitative exercise. Okay, so only take 2 minutes. These ones are actually kind of easy exercises, so you should take less. You should do your best to finish before the 2 minutes. So remember, this one is data sufficiency. Okay, so actually you will have 5 answers here. If you don't know what I'm talking about, then go back to the introduction video. Okay, you should already know how data sufficiency questions work. So in this case, you get 2 minutes. Okay, so let's do it. Okay, in each data sufficiency question, the first one, basically letter A, B, C, D, you have 5. The first one would tell you that statement number 1 works alone, but statement number 2 doesn't work. I mean, it's not sufficient to get the answer. Letter B would be telling you that statement number 1 doesn't give you the answer, not enough. Statement number 2 alone does. Letter C would tell you statement number 1 alone doesn't give you the answer. That statement number 2 doesn't give you the answer either, but once you combine them, they do give you the answer. They're enough to give you a definite answer. Letter D would be telling you that either 1 or 2 alone on their own would give you enough information to get an answer. And letter E would be telling you that 1 alone doesn't give you enough information, 2 alone doesn't give you enough information either, and then if you combine them, you can't get enough information. So there is no way you can get the answer with that info, okay? Now here we have one equation, x is equal to 6, y, z. They want you to find the value for z. But in this case, what you have to know is if we apply our basic theory for algebra, if you have 3 variables, on theory you would need 3 equations, right? 3 equations. You only have 1 equation here. So if you get number 1 here, you get the same 2 variables, x, y, and y, right? But then you would have only 2 equations. Will you be able to find 3 variables with only 2 equations? Most likely not. Okay, so the first one, we could cross out letter A. We could cross out letter D also. Now, let me change colors here. Now, if you choose B, the same thing, you have 2 equations. You have this equation here, number 2, and you have the original equation. Notice when I check for the second one alone for B, right? If I check for B, I don't really care about number 1. So I'm basically ignoring number 1, okay? So if I have number 2, I only check 2 with the original one, and 2 alone doesn't give me any information because, I mean, it does give me some information, but it doesn't give me enough, right? Because I only have 2 equations and I needed 3 equations. So 2 alone is not the answer either. So we have only 2 options. It could be the 2 of them combined, or it could be only that we wouldn't get an answer. What happens if we combine these 2? Then we have 3 equations, right? We have equation number 1, x is equal to 6y, z. Equation number 2, you have x is equal to 8 minus y. Equation number 3 is equal to 3x is equal to 4x. Actually, here you know that x is equal to 0, actually, right? That's the only possible answer. So if you substitute 0, you don't need to do that, but this time you already know you get an answer. It's possible for you to get the answer, and you must choose C. But if you want to prove it, or just because you want to practice more, okay, you get that x is 0 here, and then you have a value for y, right, which is 8. And you already have x is equal to 0, y is equal to 8, and with that you can find the value for z, okay? But you don't need to do that. As soon as you know you have 3 equations, and you get 3 variables, you know that it will be possible for you to get the answer. The only thing you have to check for is that you truly have 3 different equations. Okay, let's not fall in traps here. Fine, this one was a very easy question. Now let's go to the next one. Okay, this one's an exception, okay? Because what exception? We mentioned before that you need the same number of equations for the number of variables you want to get, okay? But not always, okay? We're gonna see why, especially when they give you multiple of 5. I'm gonna show you. So here to tell you. Broad bought only 2 types of comic books, Japanese and American. Japanese cost $15 each, $15, and the Americans cost $29 each, okay? How many of the Japanese comic books did Bro buy? So basically what we have is, all right, we have Japanese times 15 plus American times 29 is equal to something, the total, right? Total in money, actually, okay? So you purchase a certain amount of Japanese comic books, 15 each, and a certain amount of American comic books that cost 29 each, and you spend a total amount of money. Now, let's see the first one. Bro bought more American comic books than Japanese comic books. Okay, it should be American actually, okay? What will happen? So the Americans are greater than the Japanese, okay, but we have no restriction though. So let's say if the Americans are 2, okay, this value would be 48, right? 48 here. Actually, not 48, this 30, so it would be 58, I'm sorry. 58. Americans, Japanese could be 1, right? So you get 15 and you get the total for 15 plus 58, which would be equal to 73, right? Is that possible? Yes, because we have no restriction. We also could have, so in that case, A would be 2 and J 1, which would basically comply with this info here. But we can also have different combinations, right? We can have A being equal to 3 and J being equal to 1. For example, A could be equal to 3. In that case, you have 87 here, right? So 3 times 29, 87. And then you get here 15, right? Because J is equal to 1. In that case, you get what? 103, right? 102, I'm sorry, 102. So you get that, okay? 102. Is that possible? Yes. Why? Because we have absolutely no restrictions whatsoever, okay? So number 1 is not going to be enough. It gives you different answers. That's not what we want. We want to get to one definite answer. Now, what about number 2? Let's check. Let me erase everything I've done here. And they give us the value for T actually in number 2, right? They tell us, Bro bought $305 worth of comic books in total, okay? So let's say this one is 305, all right? 305 total in comic books. What will happen in this case? We already have one restriction, which is the total number. Now, let's notice something though here. This one is a multiple of 5, 15. That means that whatever I multiply, whatever value of J is, and I multiply that by 15, this will end in 5 or 0 only, okay? And when I subtract this that ends in 5 or 0 from 305, that will end also in 5 or 0 only, okay? So that's going to help me what? Find the value for A. Why? Because I know that whatever multiplied 29 by has to end with 5 or 0, okay? So let's try that out. If I set A to 1, 1 times 29, it ends with 9, so that's not going to be, all right? Because I need my 29 times A to end with 5 or 0 only. If I set A to 2, this one ends with 8, to 3, this one ends to with 9 times 3, 7, and so on. 4 is equal to 6. 5 is equal to 5. So there we go. The value for A could be 5. Okay, but let's keep on looking. That's 6, 4, 7. If I end with 7 times 9, 63, 3, 8, 72, 2, and then we have 9, 81, and then 10, 0. Okay, so that's another one. A could be equal to 10 also. And we already know the pattern. So if you multiply 9 times 5 or 10, that's going to end in 0 or 5. Then 15 maybe, right? But what happens with 15? You have 29 times 15, you get 45. 10, 14 here, 29 here. So you have 5, you have 13, 4, 35. That's over 305. So that's not good enough. So 15 is not a possible value. You only have 2 possibilities here for 29 multiplied times A to give you 5 or 0. A could be 5 or A could be 10. That's the only way we can do this. Okay, so let's try that out. What we're going to do is we're going to get A being 5. If A is 5, 29 times 5 would be equal to what? 45 10, 14, 145. If A is 10, that will be equal to 290. Okay, so let's first try it out when A is equal to 5. So you subtract 305, which is this number, from 145, right? Subtract 145 and you get what? 0 here, 6, 160. Okay, 160. Now, can J times 15 get to 160? Is that a possibility? Let's divide 160 by 15. And you get here 160 divided by 15, you get 1 here, 15 here, and you get 10. So that's not an integer. Then we know that it's not possible for us to have that combination, because whenever A is 5, J is not an integer. And we need an integer because we have an integer number of comic books, right? He cannot buy 1.5 comic book. He can buy 1, 2, 3 comic books only. So that's not an option. Let's try A times 10, or A is equal to 10. You get 290. You subtract 305 from 290. You get 15. And of course, if you get 15 here, the value for J would be 1. So that's the only option here. So J being equal to 1 and A being equal to 10. Okay, so just by looking at the restrictions here, even though we only have one equation, we can get the answer. Why? How do you identify this? Because they gave you multiple of 5. Okay, so that's going to be possible in very, very seldom cases. Now we've got number 3. Okay, number 3, you have 2 minutes to do it. Try this out, and then I'll solve it for you. This one's an easy one, but it involves some word problems, so you have to be careful with how you establish your equations. Tony is now 15 years older than Peter. Okay, so the first thing you write down is Tony is equal to Peter plus 15, right? If in 5 years Tony will be twice as old as Peter, Tony plus 5, which means Tony plus 5 years, is going to be equal to twice as old as Peter, 2 Peter, right? But 2 Peter plus 5 also. That's the thing. Why? Because Peter also ages 5. That's the thing. Okay, if you just say 2P, it means P is the age of Peter right now. But here you're saying 5 years, both of them age 5. So Tony plus 5 is equal to twice Peter plus 5. How will Tony be in 8 years? So they ask you for Tony plus 8. That's the actual question. So what are we going to use here? We are going to probably substitute something. Okay, so we're going to substitute this one in here. So T, right? So it becomes P plus 15 plus 5. P plus 15 is being substituted by T. Is equal to 2P plus 10. Okay, so this one's P plus 20 is equal to 2P plus 10. Here you have P is equal to what? To 10, right? Peter right now is 10. If Peter is 10, Tony is equal to 25, just by here putting 10 here, right? So if Tony is equal to 25, in 8 years, Tony will be 33. There you go. Okay, simple, easy. The only thing for you to do is to make sure before you do the operation, which is very simple, to establish your equations correctly. Remember before we talked about the common traps or the common mistakes people make on the GMAT quantitative section, right? Establishing equations is, I think, the biggest one. And the second one being time management. Most people have their operations fine, okay? Their arithmetic, their algebra is okay. But you have to be careful when you interpret these word problems and you put them into numbers, okay? Let's go to the next one. So here we have the fourth one. You have 2 minutes to do this, and then I'll solve it with you. Okay, so let's go over this one. A famous gamer sold sweaters imprinted with his logo. All right, the gamer paid the supplier a one-time setup fee of $200. So that's $200. That's a total cost. Let's say cost. And qualify for the supplier quantity discount of Y cents per sweater and pay this number for each of the Q sweaters. So the cost is this fixed cost of 200 that he pays, then plus what? Plus quantity and the cost per the variable cost. What is the cost per sweater? Is this one, 12 minus Y100Q times what? Times the number of sweaters he bought, times Q. So that's your actual, this is your total cost. The first one, 200 being the fixed cost, and the other part being the variable cost. And they ask you for the actual value of Y here. Y. What is Y? Right? So we have here 3 variables, one equation. We're not going to be able to make it. Now, number 1 here. Start with number 1. The gamer purchased 500 sweaters. Or 500 sweaters, sold each sweater for 35 and made a profit of 4. Whenever they mention profits, we have to have this equation clear. Profit is equal to the revenue minus the cost. So they're saying this whole thing here is the cost, right? This whole thing. So you made a 450 profit. You have the revenue also. What is revenue? Quantity times price, right? So you have 500 times 35. You already have the revenue. Here 500 times 35, right? You also have the number for Q, right? Because this one's the number for Q actually. So you already have this number here. And then you can, with that, you can get the cost, right? Because you have 450 is equal to 500 times 35 minus the cost. You can get the value for C, for the cost. So that gives me the answer yes. Why? Because through this equation, I can get the value for C. They are giving me already directly the number for Q, the value for Q. So all that's left to do is for me to operate this equation here and get the value for Y. That's the only thing I will be looking for. So that gives me the answer. Okay, I don't need to get the answer. I just know it's possible for me because I know my theory, my basic theory for equations. All right. Now, what about number 2? Let's change colors to sky blue. Okay, do you like sky blue? All right, leave a comment if you like it. Now, number 2. In addition to the 200 setup fee, all right, in addition to this, the gamer paid $8 for each sweater. So basically, they're telling me this whole thing here, this whole variable cost, right? Actually, without this Q here, I'm sorry, just that side here on the left. This whole variable cost is $8 times Q. So actually, you get something like this: 8 in addition to the 200, right? You paid $8, which is 12, basically 12 minus 100 Q will be equal to 8 times Q. Okay, what happens with this though? I have 2 variables and only 1 equation. Not gonna be enough. That's not gonna be enough. It's not gonna make it. Okay, so answer here would be A. You see how easy this is? If you're having fun, if you like it, leave a comment below. Show some love. Okay, and also share this video with your friends and family. Okay, so now we're gonna go on to the most important, let's say not most important, but most challenging concepts. Now we're going to start with chapter number 2. Don't forget to subscribe to our channel and click on that notification bell so you receive a notification each time we upload a video. And don't forget to leave a comment to tell us what you think about this lesson. Okay, also if you have any questions regarding the theory, leave a comment. A lot of people send us WhatsApps, okay, and our WhatsApp channel is only a sales channel, only for clients. So you're not going to get an answer there. If you have any questions from this video, leave a comment below. Also remember to download our free PDF with 100 GMAT exercises. Now we're going to start with exponents. Exponents is also an easy lesson, okay? Most of that theory, you will remember it from high school, okay? That's the thing. That's why these are easy, because you are not going to see anything new. We're just refreshing your memory basically up to this point. So go in there and see what things you need to remember. Perfect. So now we're going to talk about exponents, okay? Exponents. Now, I'm pretty sure you already know the properties of exponents and you learned them while you were in high school, right? We all did, okay? So I'm not going to go over each of the properties here because that'll be a waste of time. What I'm going to say though is this. Just look at these properties, remember them, you know them already, okay? Because you have to memorize them. But the important thing is this. A mistake a lot of people who are not good at quant make is the following. They get confused between the properties and factorization, okay? Notice that all these properties are only applicable when you are multiplying or dividing, okay? If you multiply or divide bases, numbers, right? Then you apply the properties, like this one, like the most common ones, right? Now, if you are adding, for example, 8 to the 5th plus 8 to the 3rd, you don't apply any of these properties. When you're adding or maybe subtracting, what you apply is what? Factorization, okay? That's a very common and basic mistake. Okay, if you add or subtract, you apply factorization. That should be your first instinct. If you multiply similar bases, then you have to use these properties here. Okay, having said that, let's go and now try to solve some questions. Okay, again, you have 2 minutes here. This one is an easy one. Let's go. All right, the first thing I see is that they're adding. They're adding a number with the same base, actually, the same exponent. So what do? We just have to factorize. If they're adding, immediately our first instinct should be to factorize, right? So I'm going to factorize 6n. I'm going to be left with 1 plus 1 plus 1 plus 1 plus 1 plus 1. 3 and total of 6. So this is saying 6n times 6. 1 plus 1, 3 times 6. I'm sorry, 6 times 1 is 6, okay? And then that's equal to 6 to the 18. And then we have a multiplication here, which is the same thing as this is 6 to the 1. So n plus 1, because when you have similar bases, you have to add the exponents. It's equal to 18, so n is equal to 17, and that's my answer. Pretty simple, very easy, okay? So whenever you see an addition of exponents with similar bases, then you have to factorize, okay? Good, easy. Okay, so this is the second one. You have 2 minutes. Let's start. Nice, so what do we do here? Again, we notice they are doing something. They're adding, right, similar base on the numerator. So what you have to do is you have to factorize somehow, right? A lot of people will try to factorize a number that is the greatest, okay, in this case, because minus 11, it looks like it's more than minus 13. But in fact, it is not, okay? I'm going to show you why, okay? Because when you have 3 to the minus 11, that's the same thing as saying 1 over 3 to the 11th, okay? And if you have 3 here to the minus 13, that's the same thing as saying 1 over 3 to the 13th. Which one is greater? This one here. That one's greater, okay? Why? Because you are dividing 1 by a smaller number. So that's greater, and this one's greater, and this one's smaller, okay? So pretty simple again. So what we're going to do is we're going to, let's see what happens if you if you factorize 3 to the minus 11, which a lot of people do, right? You're going to get the answer, yes, but you're going to have to do some additional steps. So you have that 1 here, you get 1 here, you get 3 minus 1 here, you get plus, this one becomes 3 to the minus 2 over 13, okay? Then this becomes, let me change colors here, this will become 1 plus 1 over 3 plus 1 over 3 squared, okay, 1 over 9. So you want to change them all to 9s. This one will become 3 over 9, and this one will become 9 over 9, right? Is that okay? Yes. And then what do we have? We would have something like 9 plus 3, that would be 12, 13, 13 over 9. That's what we have here. This whole thing is 13 over 9. And these two 13s cancel out. So you'll be left with 3 minus 11 to 1, 3 square, which is the same thing as saying 3 to the negative 2. Okay, so we have 3 to the minus 11, 3 negative square. Okay, that would be the same thing as saying 3 to the negative 13. So this 3x is equal to that, so x is equal to the negative 13a. Okay, but that's not the fastest route. Our fastest route is going to be this, to factorize. Let me change to green. This guy here, that's the biggest number. So we have 3 to the minus 13. 3 to the minus 11, what does it take to become 3 to the minus 13? Actually 3 squared, right? Plus 3 to the 1 plus 1. That's basically what you have over 13. That's a factorization. And then you have 9. This is 3 squared 9 plus 3 plus 1 is 13. So this whole thing is 13. So that whole thing gets cancelled out here. And you have 3 to the minus 13 is equal to 3x. X is equal to minus 13. There you go. Same answer, fewer steps. Okay, so that's how you do it. Now we're going to go to the quadratic equations. Okay, what is a quadratic equations? Let's read this. It's an algebraic expression that contains the maximum value of the second degree square and is represented by a parabola. Okay, on the coordinate plane, basically. So if you have a coordinate plane or something like that, it will be represented something like this. Okay, or something like this, or like this, or like this. Okay, that's a parabola. Now, a quadratic will contain one variable raised to the second power. One variable always raised to the second power. So in this case, the variables are x, right? That's a variable. A is actually a constant. The same thing as b is a constant and c is a constant also. Okay, x is a variable, so one of the variables will be raised to the second power, square, and one variable raised to the first power. In this case, this second x is raised to the first power. Additionally, the quadratic equation will usually have two solutions. Okay, that's an important thing. Whenever you are solving a quadratic equation, you have two solutions, normally. Okay, now, if you want to do this quadratic equation and find the solutions, you have to make it equal to 0. 0 at all times. So on the other hand, should be blah, 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 equal 0. Okay, if you have a number, for example, here, ax squared plus bx plus c is equal to 8. Okay, the first thing you want to do is to move this 8, subtract it on the left, right? You will be left with ax squared plus bx plus c minus 8 is equal to 0. And then you can start looking for the solutions and the factors, etc. Okay, so that's the first thing. The quadratic equation is a parabola. The quadratic equation contains one variable raised to the square, right? And the other variable just in the first to the first power, and you will be making it equal to 0. Okay, that's the first thing. Then second thing. Now, when you have a quadratic equation, you will have something like this. All right, so you have the factors, right? You have x here, plus or minus something, and then a number. Let's call them alpha and beta. Okay. Now, alpha and beta, how do you find them? Usually, it will be easy to find them. Okay, you won't need the quadratic equation. There's a quadratic equation. Of course, we all learned that equation in high school also. That's not necessary on the GMAT. Okay, how do you find these values, alpha and beta? Basically, alpha plus beta must be equal to b here. Okay, and then alpha times beta must be equal to c here. So that's the thing. That's how you get it. So two numbers that when they are added, they give you b, and two numbers that when they are multiplied, they give you c. And that's what you get for. And these are called the factors. Okay, it's important that you know how they are called, because those are factors. What is a factor? This is one factor, and this one on the right is another. So you have two factors for that quadratic equation. And then what do you get? So if you have, let's say, alpha here, let's say plus alpha, plus beta, let's say those two are positive, okay? Then with that you can find the solutions or roots, which those two are synonyms, okay? So what are the roots? Whatever makes this 0. So in the case of alpha, there'll be negative alpha, the opposite, right? It was positive alpha, so it would be negative alpha. In the case of beta, it was positive beta, so your other solution would be negative beta, something like that. Okay, so those two would be solutions or roots. Basically, they are the points at which this parabola intersects the x-axis. All right, so that's what you get. That's what there is. Okay, so let me give you an example. If you have, for example, x squared plus 6x plus 8, okay, is equal to 0. What do you get as factors? Let's see. You get something like x here, x here. Now, two numbers that when you add them, you get 6. And when you multiply, you get 8. So let's start with 8. How can you get 8? You can get 1 times 8. You can get it saying 2 times 4, right? Those are the only two ways you can get 8. Now, if you have 1 and 8, that doesn't add up to 6, does it? If you have 2 and 4, that does add up to 6. So this one should be 2 and this one 4, or 4 and 2, whatever, right? And there you have the factors, okay? Because 2 plus 4 is 6 and 2 times 4 is 8. And then you go and say, okay, if these are my factors, then my solutions are going to be negative 2 and negative 4. There you go. That's how you solve this quadratic equation. It's very simple, okay? As so simple, a caveman can do it, okay? So let's go here to number 3. You have 2 minutes, and after that, I will guide you. All right, so how do we do this? If 6 is one solution of the equation blah, 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 where k is a constant, this k is a constant, k is actually taking the value of c, right? We already noticed that. What is the other solution? Okay, so 6 is one solution. Let's go here and first let's give this a little twist to make it, give it the format of a quadratic equation where we can work at. So here we first have to make it equal to 0. So you have x squared plus 4x plus k minus 10 is equal to 0, okay? There you go. So here, it's important for us to notice this one is A is 1, this one is B is 4, A, B, and this whole thing is C, okay? Perfect. So they told us also another, they gave us another piece of data here. 6 is one solution. Here we have factors. They're gonna be x something equals 0. And then the solutions or roots will be here. So 6 is one solution. That means that the value here is the opposite, negative 6. Okay, so we already know that negative 6 is one of the solutions, and we already know that negative 6 plus whatever is here, right, this value here, must be equal to 4. So we already can get it, right? So what must be, it should be 10 actually, right? 10 plus 10, negative 6 plus 10 is equal to 4. Now, if this value here, accompanying x plus 10, right, is positive 10, then the solution will be the opposite, which is negative 10. You see? A. Easy. Very easy. That's the second solution. Okay, now let's go to the next one, number 4. Remember, these ones are easy. Okay, so try not to take the 2 minutes. Try to do it in less time. Okay, that's going to be good for you. So this one is actually a little bit harder, but let's go with this. 3, 2, 1, let's go. Okay, so you have Arnold. He convinced N people to donate 500 each to his charity fund. And then each of these N friends convinced N more people to donate 500 each to Arnold's charity fund. No one donated twice or more than once, and there were no other donations. Okay, the value for N. So first we need to get the equations. Okay, Arnold convinced N people to donate 500. So the first N people donated 500 times N. N people donated 500 each. What happens then? Each of these N friends convinced N more people to donate. So you have here N 500. So the second people that were contacted by these first N people were N squared, right? Because each friend, let's say you have 2 people, and those 2 people each contacted 2, so it's 2 times 2, so it's 2 squared, you see? So in this case, you have N squared for the second people which were contacted by the first ones. And that's the whole thing. That's equal to what? Equal to the total funds. Okay, total amount you receive from donations. Okay, so then they're asking us what's the value of N. Okay, we already know that's a quadratic because we have one variable to the square. Okay, now what about the first one? The first one tells me the first N people, this one, donated 1/16 of the total amount donated. Okay, 1/16. So how are we going to do that? So we can do basically, this is the total amount donated. So we can get the first N people, 500, and is equal to 1/16 of the total amount, which is this whole thing, right? 500 N plus 500 N squared. Are we going to be able to get the answer? Probably. We know we're going to get 2 answers. Okay, we have to see if we get one negative and one positive. Of course, let's say if at the end we have 2 solutions and we get -5 and positive 10. right? We cannot use -5 because in this question, they're asking us about people, right? And it's supposed to be people. And you're gonna have -5 people, okay? So the negative answer would be eliminated, and then you only be left with the positive one. Okay, so let's see what we get. Okay, but we definitely are gonna get 2 answers. Now let's see. Okay, so we have this one. The first thing we do is we multiply 16 to the left side, right? So we get something like 5,000, 8,000, right? 8,000 n is equal to 500 n plus 500 n squared. We want to give this the same format as any quadratic equation that we can work with, which means we have to make it equal to 0. That means we have to bring this to the left. So we have at the end 0 is equal to 500 n squared minus 7,500 n. Okay, so you would be asking, what's the value of z? Z in this case is 0, right? So you have n squared being, 500 being a, right? 7,500 being b, and then you have plus 0, and z would be 0. Okay, and we already know though that if z is 0, one of the solutions will be 0 also, okay? So by this time we already know that we're gonna get only one answer besides 0. You cannot have 0 number of people. N cannot be 0 just because of the way the story is stated, okay? So we already know we have the answer with 1, but let's just, for the sake of practicing, continue with this, okay? Okay, so what I'm going to do is I'm going to factorize, all right? I'm going to factorize 500 n. And we get here n minus 15, and that's it. It's equal to 0. Okay, so we have two solutions. This one could be 0. If this n is 0, the whole thing becomes 0, or this one could be 15. Okay, that's the thing, because if you make n 15, then the whole thing would be equal to 0. Okay, so that's the thing. That's the thing. And then 15 is my answer here. Okay, but we should have already known that here by maybe not get the exact number 15, but we should have known that we already had an answer. Okay, so that's number 1. Let's see number 2. Okay, let me go and remove this. Okay. Number 2, the total amount donated was, okay, so you get 500 n. That was my initial equation, right? Plus 500 n squared. That will be equal to the total. The total, they're giving you a number here, 120,000. Okay, that's it. So this one becomes C. You basically take it to the left, you subtract it to make it equal to 0. Then you factorize 500. You are left with n squared plus n minus, what's 500 of 12,000? Okay, here you get 240. All right, that'll be equal to 0. So here we get two numbers that when they are added, there is a difference of 1, right? But when they get multiplied, they get 240. Okay, so what numbers could give you 240? That's a question. That's a big question. So if it ends with 0, most likely you have some 5 involved, all right, or 10. So it could be 10 and 11. We know that doesn't give you 240. It could be 20 and 21. That gives you over 400. So that's not going to be it. We're going to try 5 and 6. Of course, that doesn't give you 240. And we're going to try maybe 15 and 14 or 15 and 16. Let's try that out. If you have 15 and 14, how much you get? 20. 5, 7, 14, and you get here, yeah, 210. That's not good. 15 times 16, however, gives you 30. 6, 9, 15, and that's, there you go, 240. So it's 15 and 16. But then this one is a positive one, so you have n, and here equal to 0, right? This one is a positive one. That means that greater number is positive. So it's plus 16 and minus 15. But once you find the solutions are the opposite, right? So there's minus 16 and positive 15. So you cannot take the negative because of what we mentioned before. We're talking about people here. You cannot have minus 16 people. That's out. So the only solution is positive 15. Okay? So there you go. There you go. Now, the important thing is this. By this stage here, let me highlight this, because that is efficiency, right? You are not being asked to give the exact answer. And that's important for you to recognize when you already have an answer, a possible answer, for you to stop, give an answer, and then don't waste any more time, okay? By this stage, you should already know that you're going to get an answer. Why? Because you have something that when multiplied, you get 240, right? Negative 240, actually. And when they are added, it's a positive number. So that means one of them is negative and the other one is a positive one. Okay, we don't have to test the numbers, actually. We don't have to try to get them, but we know there's going to be one positive number and one negative number, and that's enough for us to know that there will be only one solution. Okay, so this one is an intermediate problem here on the GMAT. Okay, so now let's go to the next one. What about this one, number 5? So you have 2 minutes. 3, 2, 1. Let's start. All right, so let's say a is negative 0.8. Well, which of them is true? So you have a raised to the third power cube and a square. Okay, what we have to know is whenever we have a negative number, right, a, and we raise it to the second power, square it, then that becomes a positive. So in this case, a square will always be greater than a, because a is a negative, a square is a positive. So we first have to look for that. For example, we can remove c, because a will never be greater than a square, because a square is positive and a will be negative. Okay. Now here, for example, this one also wrong, e, right, because a shouldn't be greater than a square. So that's the first thing. Now what's the second thing? When you have a cube, right, when you have an odd number as an exponent, what happens is that you keep the same actually, in this case, positive or negative, right? The same direction. So the same charge, let's call it, right? As if we were studying chemistry, something. So the charge is negative for a, and if you raise it to the cube or the fifth or the seventh, any odd number, it keeps being negative. Okay. However, if you raise it to any even number, it will become a positive. So in this case, a cube, right, will be also negative because a, the base, is negative. Okay, so that means that a square is also greater than a cube, because a square is a positive, a cube is a negative. So let's see, a cube cannot be greater than a square, b is out, and those two are the ones that we're left with. Okay, so now let's see, everything is about determining whether a cube is greater than a, or if a is greater than a cube. Now, what theory are we going to use? Let's see. So when you have a number that is between 0 and -1, okay, let's say 0.5, okay, here, which is 1/2, right? -1/2. And you raise it to any power, it becomes greater, which means it becomes a smaller number, but as it is a negative number, it becomes less negative, all right? So it moves to the right. Okay, that's different from other numbers that if you have something that is less than -1, it will go to the left. The same thing happens on the other side, right? So if you have a number that is between 0 and 1, okay, once you square it, it goes to the left. Or once you raise it to any power, it goes to any positive power, right? It goes to the left, okay? Whereas if a number, the base number is 1 or greater, it tends to go to the right. Yeah, it goes to the right. So that's the thing. So if we are, we have a number between 0 and -1, once we raise it to any power, it will move to the right, which means a cube is greater than a. Okay, so in this case, we get D as the answer. There we go. Okay, that's how we do it. Easy. And now we're going to do this one with radicals. We have to say this. A lot of people don't understand it. Okay, and that's something very basic. A radical is the same thing as exponent. Okay, how come? Because of course, when you have, I don't know, a square root of 2, okay, that's the same thing as saying 2 raised to the power 1/2. Okay, so basically this number, the numerator goes along with 2, 1, right? And the denominator goes here. So that's what it's happening. So if you have something like radical of, I don't know, 8, a, and here cube, that's the same thing as saying a raised to the 3/8. Basically, how is this helpful? Because all the properties that we saw for exponents are applicable to radicals because they are the same thing. Okay, they are just fractional exponents, but the whole thing applies. So now let's do this exercise. Let's see how you do. Okay, if you remember your basic algebra from high school or maybe middle school, okay, maybe middle school, and then let's come back here. So you got 2 minutes. Okay, so this is radicalization, right? We don't want to have radicals that are in the denominator. So somehow we just want to remove this radical here. How do we do it? So we want to multiply this value for something else that will remove radical 8, all right? So we have, here we have 3 plus square root of 8. And then we have to multiply times something. What we multiply it for would be the opposite sign of this expression. So 3 minus square root of 8. And we have to multiply that on the top too. 3 minus square root of 8. Okay, of course this one is 1, right? So we're just multiplying it times 1. Now, what happens if we do that? Let's see. On the numerator, we get 3 minus square root of 8. On the denominator, we get 3, which is 9 here in this case, minus 3 square, or plus 3 square root of 8, minus 3 square root of 8, and here minus 8. So these two get cancelled out, and you have 9 minus 8, which is equal to 1. Okay? So pretty neatly, you're only left with 3 minus square root of 8. Okay, for this whole expression, so you are left with this. This one, square root of 8, plus, and here you have 3 minus square root of 8. You cancel this out because you are subtracting them, and you are left with square root of 3. Pretty simple, pretty simple. Okay, so if you like this video, or if you like this course, and I know you like it, just show some love. Leave us a comment and also share this video with your friends. All right, and now let's move on to the next chapter. Okay, so finally we get to chapter number 3, number properties. Now, things here get interesting, okay? Because this is the first true GMAT theory or section, okay? In the last two theories, you didn't really have to learn anything. You just have to remember things you have already seen in high school, okay? But number properties is a little different. Most likely, you haven't seen these things in high school. Okay, so there are a lot of tricky things, a lot of sneaky things here in number properties. So just pay very close attention to it, okay? Because number properties, this whole theory, this whole section, this whole chapter we're going to see right now, is one of the cores. Okay, one of the cores of the whole quantitative section. Perfect, so now we're going to start with number properties, okay? The first thing we're going to see with number properties is even and odd integers. So basically, you know what an even number is, right? 2, 4, 6, those, and odd would be 3, 5, 7, okay? So basically they tell you when you are adding or subtracting, if you add an even number or subtract with an odd number, then you get odd. So whenever those two are different, like for example, you also have odd and even, you're getting odd. If those two are different, of different kind, then you're going to get an odd number. But if those two are the same kind, right, even with even or odd with odd, then your result will be an even number. Okay, so again, if you are adding or subtracting, if you add two numbers of different type, right, one even and one odd, then the result will be odd. If you add or subtract two numbers of the same kind, even with even or odd with odd, then you get an even result. Okay, that's with addition and subtraction. Now, if you want to multiply, right, they're really simple. Right here we have even times odd is equal to even, odd is times even is equal to even times even equal to even, odd times odd equal to odd. Basically, the rule tells you whenever you are multiplying one even number, it doesn't matter the other numbers. If you have one even number, that's enough to make the whole product even. Okay, so the only way for you to get an odd number when you're multiplying is that you have no even numbers in the operation. Okay, so whenever you multiply, if you have an even number in the multiplication, the result, the product will be even. Okay, and here we go to this part here. When you have an even base raised to an exponent, the result will always be even, because think about it, right? If I say, I don't know, 2 to the 5th, that's 2 times 2 times 2. I'm always multiplying the same number, even times even times even, so it will always be even, okay? Now, if your base is odd, let's say 3 to the 10th, right? That's the same thing as multiplying 3 times 3 times 3. And I only have the number, which is all of these numbers are going to be odd. So your result will also be odd, okay? So that's what we have here for even and odd integers. This is one of the most simple number properties theory, okay? So now let's start with this one. Again, you have 2 minutes, and after that, I will solve it for you. Okay, so now let's do it. If z is an integer, is 5z plus 3 even? So 5z plus 3 is equal to an even number. We have to know the type of z. If z is an odd number, that means that this whole thing will be odd. And when you add another odd, you get an even. Okay, but if z is an even number, that will make the whole thing on the left 5z even. When you add a 3, an odd number, that makes the whole thing odd. Okay, so basically they're asking you, is there any way you can tell whether z is odd or even? That's the question. Okay, here number 1, z squared plus 4 is even. So we know that in order for this to be even, they have to be of the same kind, right? If you're adding numbers, so z squared, 4 is even, so z squared must be even also. If z squared isn't even, we know that when you raise the base to any power, that doesn't change the nature, that the type, whether even or odd of the base. So in this case, z must be even also. So we already know that z is even. Definitely, we can give an answer. So that's fine. Okay, what about number 2? Number 2 tells you square root of z minus 1 is equal to an odd integer. Okay, 1 is an odd number. So in order for this to be odd, this one must be a square root of z must be even, right? Now, if the square root of z is even, what does that tell us about z? Well, remember that a radical is the same thing as an exponent, so that would be z to the 1/2 is equal to an even. Any exponent doesn't change the nature of the base. That means that z is even also. Okay, so in this case, D. We can answer independently with any of these data, all right? So that's number 4. Let's now go to number 5. Okay, number 5 is the same thing, even or odd. Take 2 minutes at most, and then we're gonna go over this. Perfect. So if x, y, and m are positive integers, is x plus y even? So you have 3 positive integers and they're asking you about x and y. What determines whether x plus y is even or not? We have to know the nature of x, whether it's even or odd, and the nature of y, whether it's even or odd. Okay, so only from seeing data number 1, we can tell that it's not going to be enough. Why? Because it maybe will tell us something about x, but there's no information about y, and we need also y, so that's not going to be enough. The same thing happens with data number 2, right? It doesn't contain x, so no info on x. The first one had no info on y, the second one has no info on x, so alone, they won't be answers. Okay, so if we have our answers here, A, B, C, D, and E, you should already be acquainted with these answers for data sufficiency. If you are not, then go back to the introduction. Okay, it's not going to be A, it's not going to be B, it's not going to be D. Okay, it could only be C, which means using these two pieces of information together, or it might be E. So now let's try both together. With the first one, I can get maybe the nature of X. Okay, let's see. So they tell me X, this whole thing is odd. So X minus 5 times M squared plus 1 is odd. In order for this to be odd, it means both of them are odd, right? Because that's the only way we can get an odd number. So X minus 5 is odd, M squared plus 1 is odd too. If X minus 5 is odd, that means this is an odd number, right? They have to be of different kinds. When you add or subtract, they have to be of different types in order for you to get an odd number. So X is even. We already know that. X is equal to even. That's from the first piece of info. What about M? Because I think we're going to use M here as a pivot to go to information number 2. When we see M here, again, M has to be even, right? Because even plus odd gives you an odd. So an M squared even, M is even also. Okay, so we already have M is even, X is even. We don't know anything about Y so far. Let's go to number 2 with this information here. And we have M is an even one. Even minus 3 is an minus an odd is an odd, right? Square is equal to Y. The power doesn't change the nature, so Y is odd too. Why is that? So we have already enough information to answer, right? Because they were asking us about X plus Y. We needed to know the nature of X and Y, and we already have the nature. X is even and Y is odd. Okay, so the answer will be C. Easy, fairly easy. Okay, as long as you memorize your properties or your rules for even and odd numbers. Now let's go to a different theory, divisibility rules. Divisibility basically tells you that one number is multiple of another one. For example, when you say 6 is divisible by 2, it means that when you divide this 2, you have an integer as an answer, right? Actually 3. If you have, for example, 6 divided by 5, then you get a decimal, right? That means 6 is not divisible by 5, right? If you have decimal numbers, then that's not divisible. So in order for something to be divisible by something else, it means that when you divide it, you have an integer, all right, as an answer. So how do you know that a number is divisible by 2? So all even numbers are divisible by 2 except 0. Okay, so any even number, anything that ends with 2, 4, 6, 8, or 0, except for 0, maybe it's 10, 100, whatever, that will be divisible by 2. Okay, so pretty simple to know when something is divisible by 2. Now, how do you know that a number is divisible by 3? You sum all the digits and then check if it's divisible by 3. For example, let's say we have the number 3,941. Let's say I want to check if that's divisible by 3, which means that if I divide that by 3, it's an integer without a remainder, right? So what I'm going to do is I'm going to add all these digits. So 3 plus 9, 12, plus 4, 16, plus 1, 17. The sum of these numbers is 17. And I know that 17 is not divisible by 3 because 3 is 15 and then 18, right? So 17, this number is not going to be divisible. Okay, so that's how you check for divisibility by 3. Divisibility by 4. The last two digits, not the sum, are multiple of 4. So for example, if we have 3,940, is that divisible by 4? Yes, easy, right? Because the last two digits are divisible by 4, 40, okay? That's the first way you can find out whether a number is divisible by 4 or not. But there's another way, basically, which means only take 2 halves of it. So if you can get 2 halves of the number, then that's divisible by 4. For example, if you have 640, okay? And you take 1 half of that, 320. So that guarantees that it's divisible by 2. If you can take another half, let's say here 160, right? That guarantees that it's going to be divisible by 4 also. Okay, so that's another way in which you can analyze the divisibility by 4. Then divisibility by 4, very easy. Whatever ends with 0, other than 0, and 5. So if you have the number 4,000, is that divisible by 5? Yes, because it ends with a 0. Okay. 6, divisibility by 6, you have to check for both the divisibility by 2 and the divisibility by 3. So if you can guarantee that the number is divisible both by 2 and also by 3, then it will be divisible by 6. Divisibility by 7, that's the hardest one, okay? You have to double the last digit and subtract it from the rest of the number. So for example, let's see. You have 6,432, okay? You have to do, so how do you check if that's divisible by 7? You take the last number, right? You double the last digit, so it becomes a 4, and you subtract it from the rest of the numbers. So 643 minus 4 becomes 639. 639. So can you tell if 639 is divisible by 7? I can't, because I don't remember those multiples that are over 100. So in this case, we repeat the same thing. We get the last digit 9, double it, 18, and we subtract it from the rest of the number. 63 minus 18. What is 63 minus 18? Is 45, right? 45. Okay, is 45 divisible by 7? No, because I do know all the multiples of 7 up to 100. So 45 is not. So definitely 6,432 is not divisible by 7. Okay, that's the trickiest one. Divisibility by 8. The last 3 digits are divisible by 8, or the number is divisible by 2 3 times. Same thing as 4, right? So I think if you have, for example, 6,800, it's pretty simple, pretty easy to know that that's going to be divisible by 8, because the last 3 digits, 800, is divisible by 8, okay? But then a better way to do this, let's say if you have 6,440, okay? And you want to check whether that's divisible by 8, you take 3 times 1/2. So the first half would be 3,220. Right? That guarantees that this whole number is divisible by 2. Then another half would be 1610, right? 1610 divisible by 4. And then if you can take one more half, which is 805, that's divisible by 8. You see? So if you took 1/2 of that number 3 times, that guarantees that that number will be divisible by 8. Okay? And then 9, the same thing as with 3. You sum the digits and check if that's a multiple of 9. For example, if you have the number 4,806, is that divisible by 9? Let's see. 4 plus 8 is 12. 12 plus 6 is 18. Is 18 divisible by 9? Yes. Which means this whole number is divisible by 9. Okay? So that's how you do it. This is something you have to know off the top of your head. Okay? Now let's start here with the exercises. You get 2 minutes to do this exercise number 6, and then I will come and solve it for you. Okay, so this one's a tricky question. It's kind of the way it is worded, the way it is phrased is kind of annoying, right? So how many 6-digit integers of the form, this whole thing is one number. So it's 530,000 or 30 something thousand, 320 something, where a represents a digit that occurs twice, are divisible by 6. So let's see. Basically, they're telling you it could be 530, 320, 531, 321, 532, 320. We don't have to write this down. We just have to imagine this, all right? 533 and so on, 323. The thing is that this value would be the first A, right? And the second A must be repeated. So those are the possibilities up to here, 539, 329, okay? So we want to find all the possibilities in which this is divisible by 6. Now, in order for us to have something that's divisible by 6, to guarantee divisibility by 6, we have to first guarantee divisibility by 2 and by 3, right? So let's start with 2 because that's the easiest one. If something is to be divisible by 2, that means that it's gotta be an even number, right? So the last digit's gotta be even. So we already know that we have some options here. What are my options for this one? A could be 0, 2, 4, 6, 8. Okay, so it could be actually 530,320. That's the first option. 532, 322. Second option. 534, 324. Third option. 536, 326. Fourth option. 538, 328. Fifth option. Okay, so those are all the values, all right, in which this whole number is divisible by 2. But then we also have to check for the divisibility by 6. So how do we do that? So we know that this whole number, when we add all the digits, has to give us a number that is divisible by 3. So let's see, what's the whole addition of this? 5 plus 3, 8, plus 3, 11, plus 2, 13. So this whole thing gives you 13. 13 is not divisible by 3. Let's try this out. 5 plus 3, 8, plus 2, 10, plus 3, 13, 14, 15, 16, 18. So this one is actually 17, right? 17. Okay, so is 17 divisible by 3? No. So we already know, though, that we are adding a series of 2's. So each A adds a 2. So this one will be 4 more than the other with 21. This will give you 25. And this one will give you 29. Okay? So out of these ones, how many are divisible by 3? That's the question. Only one, right? Only one, which is 21. So, yeah, because 13 is not divisible by 3, 17 is not divisible by 3, 25 is not divisible by 3, neither is 29. So there is only one answer here that is divisible by both 2 and 3, and that's this one here. Okay, so the answer would be 1. Okay, so that's how we check for divisibility. Now let's go to the next exercise. Number 7, you get 2 minutes, and then I will come by and help you out. The product of the units digit, the tens digit, and the hundreds digit of a positive integer q is 12. Okay, so you have 3-digit number. It's called, this one is a unit, right? You should already know that. This one is a tens, and this one's a hundreds. Okay? So before that, let me just walk you through the names of things, because a lot of people just get confused. So here we have, let's say, 3,941.208. Okay. So what are the names here? This one is called the unit, right? That's a unit. This one is called the tens with an S, tens. 9 would be in this case the hundreds digit, hundreds. And 3 would be the thousands, thousands. Okay. Now on the decimals, the first decimal is called the tenth, tenth. There is no unit here in the decimal. It's just a tenth. 0 would be the hundredth, hundredth. Notice the difference at the end, right? One ends with S, the other one ends with TH, hundredth. And then the eighth would be, in this case, a thousandth. Thousandth. Okay? Thousandth, actually, like that. Okay? Very good. Okay? So, those are names of these numbers. Okay? So, basically, they're telling you have a unit, tens, and hundreds. So, it's a 3-digit number. Okay? And the product of this is 12. So once you multiply these 3 numbers, you get a 12. Okay, what is the tens digit of q? So the tens, actually q is this whole thing, right? The tens digit would be what is the value of t? All right, so let's look for the value of t. So let me change to purple. Okay, so the first thing we have to do here is we have to get all the factors of 12. So we're gonna go over that, but all the factors are gotten in this way. 1 times 12, 2 times 6, 3 times 4. Those are all the possible combinations. 1 times 12, 2 times 6, and 3 times 4. Those are the actual ways in which we can get 12. Okay, and then it could be ways within. So it could be, for example, 4 has 2 and 2. 6 got 3 and 2. So it could be, for example, yeah, it's the same thing. It could be 3 times 2 times 2. That gives you 12, right? It could be 1 here times 2 times 6. That gives you 12 also. It could be, let me draw a line here. 3 times 4 times 1. And it could be the combinations of all of this. So we don't know what the value of t would be. I mean, there are several options. So let me erase this one. There's the names. Let me go over here. So the first one, they say q is odd. Okay, if q is odd, what are my possibilities? So we have q could be 3, right? Could be 3. It cannot be 4. It cannot be 2. It cannot be 6, right? It could be 1 also. 1. So q is odd. The last digit is 3 or 1. Is that enough? No. Why? Because if u is 3, for example, t could be 1 and then h4, or h could be 1 and t4, right? Or if q is 3, right, in this case. Or if q is 1, then you can have t being 6, this one 2, or this one 6, this one 2, or this one 4, this one 3, and so on. So you have too many options for t. Okay, but at least we have something. Okay, maybe that's going to help us out when we evaluate these two answers together. So for the time being, the first one is not enough. It gives me too many options for t. It could be 1, 4, 6, 2. Now, number two, along. It says, here, let me just write this down. Okay. Now, number 2, the hundredth digit of q is 1. So this 100, this h is equal to 1. If h is equal to 1, we have h times t times u. This one is equal to 1. Well, we also have several options for t and for u, right? Because t could be, for example, 3 and u 4. T could be 4, u 3. T could be 6. This one 2. This one will be 2 and 6. So there are too many options. Okay. However, those are all my options. However, what happens if we combine them both? So the second one alone is not. Now we're going to check for C. If we combine them both, we know that the last digit u has to be an odd number, right? And then h is 1. If h is 1, the only possible value for u, which is odd, it cannot be 6, it cannot be 2, it cannot be 4, is 3. So if u is 3, then that makes t 4. That's the only possible way, okay? So 143 is the value of the whole number, and the value of t will be 4. Okay, so they're forcing us to go that way. So once we combine these two pieces of information, okay, so I know you're having fun, okay, that's easy so far, okay, because the GMAT can get much harder. Now we're going to go over to prime numbers. What is a prime number? It's a number that is only divisible by 1 and by itself, so it has no other factors, okay? So you have to memorize the first 10 prime numbers, 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29, okay? You have to know those off the top of your head. Now, here are some properties for these prime numbers. 1 and 0, even though they kind of fulfill this, they comply with this kind of definition, they are not primes. Okay, the first prime is number 2, and 2 is also the only even prime number. So all the prime numbers except for 2 are odd. Okay, that's one thing. Thing number 2, a number with only 2 factors is always a prime number. Yes, because it's only going to be divisible by 1 and by itself. A number with more than 2 factors, on the other hand, is not a prime number, right? If you have 3 or 4 factors for a number, that just goes against the definition of being a prime number, right? So that's not a prime. And then there are infinite prime numbers, right? The list of prime numbers is infinite. And now we're going to go over factorization. There are 2 types of factorization, right? The straight factorization here, which is the most common, and the prime factorization. When we talk about factorization, people always imagine a straight factorization. Okay, but in this case, on the GMAT, for number properties and for most of the GMAT, we care more about the prime factorization. The prime factorization is going to be more useful, more helpful. Okay. Now, what is a straight factorization? Let me show you. If you have something like 120, you make a little t here, and you start seeing different combinations in which you can get 120 starting from 1. So you get 1, 120, right? 2, 260, 3, 340, 4, 430, 5 is not. Actually, this one's wrong. 6, 620, yes, 6 and 20. 8 and 15, yes, 8 and 15. And then you get 10 and 12. 10 and 12. So those are all the possible options, all the combinations you can get 120. Now you know you cannot go 11 here because then the numbers start overlapping. You see? So you have 1, 2, 3, 4, 5, 6, 7 combinations, actually 14 numbers, 14 factors for 120. With this, what are you getting with this? What you're getting is all the factors for 120. Okay? All the possible factors. Now, however, if you go with the prime factorization, what are you going to get if you do the prime factorization? You're going to get the prime numbers. You're going to decompose the number. You're going to decompose it to the prime factors, only the prime ones. Here, for example, when you do the straight factorization, you get all the factors, some primes like 3 and 2, and most of them are not prime, right? But with the prime factorization, you get an expression only with prime numbers. So if you have 120, what do? You do a little tree, right? Let's say you start with 12 and 10, right? You try to get all that number to and decompose it only to prime factors. So 10 and would be 2 and 5, right? So I cannot go any further here on the right. I'll go on the left. 12 is the same thing as 6 and 2, and 6 is the same thing as 2 and 3. So there I have gotten all my prime factors. So I count how many 2's I have. I have 2, 3 times 2, right? 2 here, 2 here, and 2 here, times 3, 1, 3 here, times 5. So basically, that's my prime factorization. This number expresses, only using prime numbers, number 120. Okay. Now, this is going to be more helpful when we apply the theories for number properties. For example, the least common multiple, the greatest common factor, etc. Okay, so you better start getting good at the prime factorization. So let's talk a little bit of, we've already talked about factors and multiples, but let's just make it clear what they are. A factor and a multiple is like two faces of the same coin, okay? So actually, factors are numbers that we can multiply together to get another number. So 5 and 4 are factors of 20. So when we went over 120, or let's say 6 and 20, all of these are factors of 120. If you notice, all of these are either smaller or they are the same as 120. They cannot be greater. A factor can never be greater than the actual number. Okay, so the factors are basically the numbers, and when you multiply the number, that factor, by something else, you get the number that you are getting the factor from. Okay, so for example, if you multiply 5 and 4, you get 20. So 5 and 4 are factors of 20. Okay, you could also say divisors, right? 5 and 4 are divisors of 20. Factors and divisors are the same thing. Okay, now the multiple is the same relationship, just being seen or being looked at from a different angle, from a different perspective. Okay, so 20 is a multiple of 5. Why? Because if 5 is a factor of 20, then 20 is a multiple of 5. Okay, why is it a multiple? Because when you multiply 5 times something, in this case times 4, you get 20. Now the multiples are usually greater than or the same as the factor, but it cannot be less than the factor. Okay, so remember here, a factor cannot be greater than the number that you are getting the factor from, and the multiple cannot be less than the number that you're getting the multiple from, so less than the factor. Okay, now to find factors, get the largest and the smallest. That's what we've done here, right? This straight factorization. So here, to look for a multiple, you should contain the prime factorization of n. So let's say if we have a number that we have already decomposed, okay, into prime factorization, 2 cubed times 3 times 5. That's what we had, 120, right? And we have something on top of that, that is 2 cubed times 3 squared times 5 squared. Is this number here a multiple of the number below? Yes. Why? Because it contains its prime factorization. It's got at least 3 2's. It's got at least 1 3. In this case, we got 2. And it's got at least 1 5. In this case, we got 2, right? So once you start canceling out, you're going to be left with an integer, right? That's how you guarantee that a number is a multiple of another one. Okay? So that's what you do. Very good. So now let's go and let's apply what we've learned. So here we have the next one, number 11. You have 2 minutes to do this, and then I'll come by and show you the answer. Okay, so let's do this. All right, if a and b are positive integers, what is the value of a plus b? They're positive integers. So they want you to have, or to get the value of A plus B. Okay, the least common multiple of A and 3 is 6. We know that they are not saying anything about B. In order for us to know the value of A plus B, we have to know both, right? The value of A and the value of B. Number 1 is not saying anything about B, so that's not going to be the answer. Number 2, the product of A and B is 6. Okay, A and B, A times B is equal to 6. Could be 1, 6, could be 6, 1, could be 2, 3, could be 3, 2. Okay, too many options. Okay, so that's not going to give you the answer either. Now, what happens if we have both of them? Let's see. From the second one, we get this. Possible combinations for A and B. Okay. It could be 6, 1, and then of course it's different, right? Because we add them, the first one is 7, the second one is 7, the third one and the fourth ones are 5. So least common multiple of A and 3 is 6, they say. Okay, so we have A, we have 3. We get our prime factorization for A. We don't know what the prime factorization for A would be. Prime factorization for B, for 3 would be 3, right? And then your least common multiple is equal to 6, which is 2 times 3, which means somehow A must have a 2. Okay, A must have a 2. What's the matter though? What's the matter is that A could be 2. All right, some people say, okay, A has a 2, so A is equal to 2. That's not true, because A could also be equal to 2 times 3. Because if you have 2 times 3, your least common multiple will also be only 2 times 3. Right? Because in this case, you get all the primes, you get 2 and 3 with the highest exponent, which is 3 to the 1. You don't repeat. If you have more of the same prime, you don't repeat them on the least common multiple. So A could be either 2 or 2 times 3, which is equal to 6. Now, if A is 2 or 2 times 3, which is equal to 6, you have these two options here. Let me show you. A could be equal to 6. A could be equal to 2. If A is equal to 6, B would be 1. If A is equal to 2, B would be 3. And then you have two different answers, because 6 plus 1 is equal to 7, right? And 2 plus 3 is equal to 5. So two different answers. Here the answer would be E. It's not possible. With this data, it's not possible for us to know the value of A plus B. All right, so I know you're enjoying this. Show some love. Leave us a comment. Give us a thumbs up. Like this video. And also share it with your friends. Okay? Don't be selfish. So now let's go on to the next chapter. So I hope you pay really close attention and you watch every single second of that theory of number properties, okay? Because that's very important. So that has been the first part for the complete course for the GMAT quantitative section. We're going to upload another video with the other theories for geometry, statistics, probabilities, etc. Okay, so just make sure you stay tuned, make sure you have already subscribed and clicked on the notification bell to receive an update when we upload our next video. And now, something you have been waiting for, something everybody has been waiting for. Our next contest. Okay, this contest again goes to the biggest Liberty fans, those people who are the most active within our social media here on YouTube, TikTok, Instagram, and also Facebook. Okay, now we're gonna include Facebook too. So basically, again, there are two prizes. The first place gets full access to our Liberty platform with over 20 simulations, with 1,000 GMAT exercises and exclusive videos. And the second place gets 2 hours of free tutoring with none other than myself. And who gets the prize? Our subscribers and followers who are the most active. The ones who basically wants to write the best comments, alright? We truly read your comments. And that's very important for us because it's like a fuel that helps us keep on going and doing this, alright? So that's it. There are the prizes and they will go to the people who are the most active. And you'll get by May the 24th. That's the date where we're going to announce the winners of the second competition. Okay, so it has been a pleasure. Just stay tuned for the next video. My name is Rod. Of course, you already know I'm with Liberty, and thank you for watching.